Hello, everyone. I believe you must be excited about the recent advances in AI, right? Many of you are planning to harness the power of these new models for your business or creating exciting new applications based on them. My name is Jiang Bo. I am a core developer of the BentoML, an open source application framework. Today, I would like to share some of BentoML's perspective on building reliable applications with a step-by-step workshop. At first, I guess many of you already knows the truth from the GPT technical report that they spent 8 months to ensure the GPT 3.5 reliable and harmless before releasing the ChatGPT. From here, we can see how big the gap is between a model and an application. We know that other than performance, OpenAI investigates a lot of time to ensure the harmless and unbiased. When we generalize this to other types of API services, it's already complicated. But what makes the situation even more complicated is that everything above also change over time, what is called drifting. And also, the data generated by the user of your services is a valuable asset of your business. It's crucial for optimization the model or even maintaining your competitive edge. So this requires us to introduce model monitoring to our application early on. So in this workshop, we will build a credit card fraud detection API services step by step and see how BentoML and Arize help on it. There will be 4 steps: save the model and develop a service and deploy. At last, we just explore the Arize and set up some dashboard and monitors. We already know that monitoring is critical for building reliable machine learning applications, but how BentoML do? Actually, BentoML has always been dedicated to building production level machine learning applications. Therefore, we have partnered with Arize to provide developers with out-of-box monitoring capabilities. So let's begin the demo. We have a credit card fraud detection model and also a data set. You will need to save the model with BentoML's XGBoost API. As you can see that the model has a method called predict to take the input, and also it is a batch inference model. So we just also specify the signatures that predict. And for now, we are already saving the fraud detect model in the BentoML's local model store, and then the next step is just to create the service.py. The service.py is a core file that defines the, you can say, the inference graph, or you can say the definition of the endpoints, the services. And as you can see that we can have a very simple here. So at first we should create a new file. We name it service.py. And we import BentoML and we import pandas since we need it to read the data. And also we just get the model we saved, brought it, and convert it to a runner. Yeah, what is a runner? Maybe let's go back to the slide. By default, BentoML uses a distributed microservice architecture to serve your machine learning application. So this approach empowered the application by allowing it to combine multiple models and scale them independently. In this way, it maximizing server resources utilization and efficiency. For example, if your service requires two models, some of them require GPU and others are more CPU bounded. You won't run them in the same process or microservice, right? So that's why we introduced the concept runner. Actually, runner is a standardized abstraction of the machine learning workload that we will run the model inference separately. So in that way, we can schedule or scale them independently and also assign to different hardware. Okay, let's go back to the demo. So here we are currently having a runner, and now we will define the service. As you can see that there's no limitation, like you can only have one runner for one service. So yeah, basically you can have as much runner as you want. What you need is just specify the runner that it requires in a dict and assign and specify it here. And now we are going to create the endpoint. As we can see that the data here is actually a data frame, and a data frame actually is a batch of data. So one single data is a series. So that's what we will want for our API. That our user will maybe just send us this series, and we will give them the result. Either is a fraud or not. So the simplest representation of the series is a JSON. So basically, we just pick the IO equal to BentoML.io.json. That basically means that this service, the input will be a JSON. The user can send us the JSON. We will also send them the JSON back. So yeah, the output is also JSON converted into a data frame. And last step is very simple now. We just call the runner call the runner on the predict and just pass in the data frame as the input. So basically, we just return in a JSON that includes the result. We include the result. Okay, so we have defined the service now, and we will define another things. That is specify the environment of this bento. For most services, it just requires some Python packages, but sometimes you may also want some Conda packaging or even NVIDIA things. But yeah, for our simple case here today, we can just specify the file.yaml just by adding the XGBoost and boost as a dependency. And also we will add a dependency name that is BentoML plugin Arize, which I will mention that later because we require this to ship the monitoring data to Arize. So it's a third party plugin for BentoML. Okay, so once we have done this, we can try this by running a simple BentoML serve point, which means we will serve from the current directory. It will go to find out the bento file there and just find out the service object there and just launch it. So let me take to the terminal. This way we can start a debug server for our services. We can try the behavior. We can see that this debug server is already on the local machine, and we open it in a browser. This is a Swagger page that you can view all the API endpoints and other functions, and even try them on this page. Since we already have the example input, we can just copy from the meter. That is just the personalized series. As we can see that once we click execute, it responds to us that the result is 0, which just means there's no fraud. And when we go back to the terminal, we can see that we have a access log here. So let's stop the server and go back to the demo. As you can see that we have created a working Bento services, but for now we will add the monitoring feature to our service, which is still very simple because BentoML have the API internally. So let's first copy these sections here, and we just add several lines. At first, we will use this API in a context manager at BentoML.monitor, and we give it a name. It is best to be the model's name, so we just fraud it. So you can also, if you have other model or other runners here, you can have several or more than one monitor here. But for today's case, we just make it simple. And now we now should identify the features and the predictions of our data. So let's take a look on the data get inputted. We can see that there are 29 columns, which has an amount column, and we went to 28. So basically, we can just log the data by the amount, by the input JSON amount, name it amount as well, and we will have to specify the row for it. The row here is very simple. It's just this piece of data is a feature or a prediction, or it's a ground truth, then it will be actual. So when we log the output, I mean the prediction, we can just log the result as prediction, and the row is prediction. And another thing is the data type, which has numerical. We can see that this is actually numerical because the amount is a number, but for the prediction, we know that it's a categorical. And then we can log more features as just as this, and we can just write a simple script, you can just write a simple for loop to record all other columns which just have the similar names. So call name equal to f to v, and then we just copy this log and we replace it with the column name. Also, we will log it as the same name, and in this case, every feature is numerical, so we just keep the other things untouched. So that's all. So what will actually happen? That's when we have this piece of code. We can go to the slide. Go back to the slide. As you can see here, for a context manager, it will be a data row, and for each log call, it will be a data column, and the name will be the column name, and the row and the data type will help BentoML to display on the Arize or other support platform. When this monitoring context will map to a table. Okay. Now that we have defined the Bento service, and once we have done the changes, we can just save the service code and just serve it again. We'll check it if it take effect. So we can just serve as well as the next time, and just go to the Swagger page to send more requests. Of course, we can change out some of the values, but it's not necessary now. Then we can go back to the terminal that we will see the access log. And when we check the current directory, we will see a folder named monitoring, and we'll find the logs there. We'll find the data log here. You can tell and follow them. And once we I will have more requests getting in, and you can see every single request is logged in JSON data, and also includes the request ID and the prediction prediction result. We are having the data monitoring working locally. We can perform analyzing over them manually, but today what we will do is to ship them to Arize so that we will have an end-to-end drift detection solutions. Let's go back to the demo, and now we will draft another configuration YAML file. So you may ask why we have another configuration that have a different name. As you can see here, what we have done is to build a bento, which is what we call for a BentoML service. And now bento is a deliverable that's ready to deploy to anywhere. You can deploy to a SaaS platform, Bento Cloud. You can deploy it as a standalone server, just like BentoML Serve. And you can also build it as an OCI image, so you can use that to deploy to any platform, just like AWS or your own Kubernetes cluster. So that's why we need another configuration file. So you must not want to hard code the Arize keys in the source code, right? Okay, so let's go back to the demo, and what we should do is just change the monitoring section, and of course we will enable it. And by default, BentoML will log the monitoring data to a local path as a JSON log. And to change that behavior, you will specify the type of monitoring here. And as you can see, we can specify it to the plugin, Arize plugin. And this Arize plugin will also have some options. And the most important are space key and API key. You can get the space key and API key from the space setting of your Arize account. Okay. So let's write it to a file, and then we should specify the deployment configuration file by passing the environment variable. Let's copy this bin and go to a terminal. You can see here it just started normally, and you just send some random request here. If you send a little bit more, and just go back, everything is okay, and we just go to the Arize dashboard. You will see this model. The first part is a service, but no service name, and the second part is a monitor name. And click in, you can see that data is already logged in, and also the columns is already there. It's correctly recognized. Let's go back to this slide. As you can see, we already have tested the standalone server, and now we will package our application for deployment to other platforms here. To package application, we just need to use the BentoML build command, and it will generate a deliverable application package, which is called a bento. So here is a project, and we can just call BentoML build, and we just need to wait a minute. Okay, as you can see that BentoML has given other two steps you may want. One is to containerize your bento, and so you can deploy it to any platform it supported. That supports the OCI image, for example, your own cluster, and also you can choose to push to Bento Cloud. Let's run bento containerize here. Okay. Also suggests how to run this, how to test this image. Yeah, everything is just the same as as a standalone cert. Okay, let's go to the last option. Deploy Bento to Bento Cloud, which is an end-to-end solution for every team that want to create AI application quickly. The usage is quite simple that we just need an Bento Cloud account and log in. I already do that on my machine, so I just need to push the Bento we just created. Okay, it tells us that this the same version of Bento is already exist on the Bento Cloud. So let's go to the cloud dashboard. Here we have pushed the new Bento here, and we are going to create a deployment for this Bento. Pick a name for example, credit card, and select the Bento you pushed and the version. And then you can just configure the resources and replicas for API server for both API server and your model. Okay. Now let's just submit this and create a deployment. All the replicas is up. Since the status is already green, we can have the test here now. Same Swagger page, just as when we deployed locally, but it is a distributed deployment and can scale up and down based on traffics. Let's go back for a summary. Today we have practiced for building a reliable machine learning application with BentoML and Arize. And by following this best practice, enterprise can ensure that their machine learning services remain reliable, accurate, and high performing over time. And BentoML invests many times to provide the best tool to running ML in production. You can join our community by the link beside, or you can contact us by email. Thanks.